Looks like everybody's here. Okay. Thank you all for coming. This is gonna be our like mock design review. You guys, like we've been saying, you guys have been putting in a lot of work for our solar installation project. And we're really looking forward for you guys to like show off what you guys know, explain it to your audience, with Sebastian and I as like the pseudo stakeholders. Just kind of talking through the decisions you guys have made and the specific areas you've been looking at and why you made those decisions. And I think, should we talk about this?
Sure.
Okay. So yeah, how this is gonna look, for those of you that will be presenting, you know how this will go. But you know, when you come up here, introduce yourself. Sebastian and I will do the project background so that we're all on the same page to start us off, and then it's gonna be purple team, yellow team, red, and then the blue and green team. And then you'll be, you know, walking through what you guys have to present, and then it's gonna be pretty like discussion based after your initial like first couple things. So if we have questions throughout, we'll kind of just like raise our hand and ask and talk through them, and then you guys can keep going. Sound good?
All right, so for the benefit of our two customer stakeholders, Chris and Bree, the background of the project was we were approached by this Peace Village community. It'll be a community for homeless and displaced people, and we wanted to provide them with a solution that provides resiliency and sustainability to that community by having a cell phone solar installation charging station. I think all the keywords are in there. So right now, a lot of the residents of this community don't have easy access to charging their phone or charging things like hearing aid. They just have no access to water and electricity and other things, and it places sort of a strain on the communities that they find themselves in when they need to request these things. So this allows them to be more autonomous and independent. So the goal was to provide something that was reliable, could sort of act as a staple of that community. And then just to go over it again, the main benefits is that it legitimizes the Peace Village sort of like structure for handling homeless people. So it allows them to gain their independence, allows them sort of like freedom from the stresses of interacting with the rest of the city that isn't as kind or as understanding of their situation. So really protecting vulnerable citizens in Rochester, providing those who have chosen this lifestyle with a sustainable solution, but also providing a safe space for people who are in a transitional period of their life. A lot of people will go to this Peace Village and then go to Halfway House. And so this is just like strengthening the system to be more impactful and successful.
Yeah, I think the next slide is, okay, it's purple team. So, awesome.
Just the arrow keys, yeah?
Yep.
Okay, so, we were working on the electronics, and, what we have is, a 6 USB port, charger with, a battery connected to the solar panel. It says for, charging about 20 phones a day, for about 3 days straight before needing to be charged up again. The things we needed for the design were an AC outlet, because we were contacted and asked for the possibility of charging things that wouldn't be able to be charged on a DC USB port. We have to have at least 6 USB ports to fill what we're trying to do. And then we wanted a weatherproof system that was contained and could be worked on pretty easily, so low maintenance.
So some of the obstacles that we faced in designing this, Rochester has a very large temperature range. So in the winter, we have to prevent things from freezing, in the summer, we have to prevent things from overheating. So especially when we were picking out like our specific electronic components, we had to go through user manuals and look at the temperature ranges and see if the components we were looking at would be viable. Also, electrical safety is obviously very important if you don't want to electrocute anyone or things overheat. So a lot of that is just making sure we're properly sizing our equipment. And something we haven't gotten to yet, which is like wire sizing and grounding. Also controlling the battery discharge. So that's to make sure that someone doesn't plug something in that'll drain battery too quickly. That's mainly through the charge controller that we have. And also finally, merging electrical components with structure. This isn't something we've gotten to yet, but it's definitely going to be a significant obstacle in the future. Just figuring out how, if we have to mount, like for instance, if we have to mount the charge controller and where the battery's going to be placed within the housing, is kind of our last obstacle. And then below there's a timeline. So the purple lightning bolt is where we are. So we looked at calculating how much power we're going to produce from the solar panel, given the weather in Rochester. We based it off of a worst case scenario, so that's a sunny winter day. And also load sizing, so figuring out the demand, that basically how much power the residents are going to use there. Some of that was also actually going and talking to them and figuring out what their needs were. And then component selection, so that's a lot of that was, sizing the battery. So sizing the battery also takes into account how much you can discharge it based on the weather. So we had to get a larger battery because of the fact that it has to withstand like -10, -20 degrees Celsius. And then we also put together a preliminary wiring diagram. So that was what we had on our poster that showed how everything connected. And then we're right now in the process of our bill of materials, so that's looking at specific components and specific pieces of equipment and going through the user manuals and making sure they're exactly what we need. And then we still have wiring and grounding to do. So that's wiring, sizing, making sure we have great wires, and then grounding it, so obviously it's safe. And then integration of electrical system and structure, as I mentioned, and then also testing, troubleshooting, and validation. That's obviously going to be an iterative process because we don't make revisions. Yes.
How far into the bill of materials are you guys?
We're a little more than halfway. We have the biggest things done. So we have the charge controller, we have the battery, we have the inverter,
We have the charging ports.
the charging ports, yeah, we have because inverter. Yeah.
Everything, the wires and breakers, right?
Yeah, we do have the breakers as well.
Yep.
All selected, so.
Do you remember how much that'll cost so far?
Probably about 500 or 500. Adding in the wiring, that would probably be another 100. So
Yeah, so battery was,
40. And the inverter and other things, charge controller for each about $80. So different things we had to consider when we were designing this was the season variability. Like in the winter, you get a lot less sun than in the summer. So we needed to make sure that our battery could handle the winter months in that way. And then different weather dependencies, like we get a lot of cloudy days here. So we wanted to see if we'd be able to withstand that type of thing. And so we have a pretty high rate of operation. Like it'll be operational for most of the time, maybe in the 90% range. But there will be some times when people won't be able to use it because if we have a long stretch of cloudy
So I already have talked about integration. And one of the things we're going to do is put conduits for the wiring because we want to make sure that the wires are protected from the exterior of the system because that can lead to a lot of wear and tear for them. So then the circuit breakers in the servicing and maintenance section, we've been kind of looking at those as to isolate different parts of our system. So if we need to do work on a certain component, we can just click one off and do what we need to so that we're protected from it. And then also they serve to cut off the battery from the inverter. If somebody plugs in like a water heater or a space heater, that'll cut it off because it'll draw too much energy. We recently talked with Dr. Stevens about our design, and he looked it over, made a couple of suggestions, helped us to improve our numbers a little bit, but he said it was looking good so far. And then we'll want to make sure that we can set up the system and test it before we actually install it there.
What questions does anyone have? Yeah, she put, okay, I was wondering. Making sure you had solved the thoughts. Okay. Sorry.
Do you want me to finish the slide or is the next group going?
If you're all set, you might as well just leave it. Okay. As long as whoever knows who's next is next.
Who's next?
That's his next. He's next, yeah. Nice job, guys.
We are Yellow Team. Our focus was on concrete foundation, things like that.
So we're looking at customer requirements and engineering requirements for this topic. Most of them are engineering requirements because this is for a foundation. It'll be below the ground. There's really no customer interaction with it. So the main thing you want to figure out here is making sure the foundation can support the weight of the bottom panel. We're looking for ways to make sure that the rebar and threaded rods are kept vertical while the cement is poured. And we're also looking to make sure that the cement pouring we do is done properly to ensure the longevity of the finished foundation.
It's kind of hard to find a lot of information on this, and mostly I do some consulting with experts. I talked personally to Rob Portman, he's the operator of the machine shop, he's done a ton of concrete and cement related projects.
And I worked with Lois Furioso, who is a professor in the civil engineering technology department. So those are the people we ended up talking to.
Took us a little while to get all things together, as you can tell by amazingly gradient cancer chart. But we figured out a bunch of stuff. So strength and durability of the cement is really one of the biggest factors. We're using 3,000 PSI cement. Generally cement comes in 3, 4, and 5. But given the base is a non-working surface, i.e. it will not be exposed to the elements or rely to be under wear, 3,000 PSI is more than enough. We've got statistics on our BOM for the rebar and the threaded rods, and our eventual design for keeping the verticality of it all was to make sure the base was leveled out in the hole by pouring a layer of weather cement. From there, we can naturally level it out, method suggested by Rob. From there, we can set the base, pour in our cement using the vibrator from the machine shop in several different batches of the same consistency to make sure the whole thing holds firm. And the rods can actually be manually adjusted and held together with a steel plate at the top, which can then be removed post-pour with nuts to keep sure our threads are free of cement, thus ensuring verticality and strength.
I'm also continuing to work with the civil engineering professor. She had suggested a different way of keeping those vertical using rebar chairs, but I'm currently waiting to hear back. So that's something else, another consideration that is possibly still in the works.
It's not important, of course, for risk mitigation purposes, that we all wear the proper protective equipment. We actually made a PowerPoint on Cement 101 for future generations, given we are heading off to co-op. But, you know, you get the mixer, you get the vibrator, it's not too hard to figure out, but, you know, gloves, you know, some galoshes, stuff like that. Yeah, it shouldn't require any service or maintenance. Ideally, you put it in the ground and don't ever touch it again. your sources with things and such. Anything else we should get on?
We'll take questions.
How do you mix concrete? Like, do you know how much mix we're using for
Yeah.
water?
So the concrete we have specifically set for 3,000 PSI strength has a recommended mix for maximum durability. You can adjust the mix less water if you want kind of something that will do vibration better, or more water if you want it to be more liquid. It will lack for strength, but it allows it to flow in different spaces. That's usually for craft applications where you're doing small pieces with lots of bends and twists. We're doing 2 blocks, so we're definitely gonna go for probably the standard blend, although it again depends on the weather at that time. If it's a very cold day, it's probably a bad idea to pour cement. Ideally, you want to shoot for a day that's not too humid, and when you're finished, cover with a layer of plastic to ensure that there's no bubbles or cracking.
Have you identified the preferred method and associated cost with mixing and pouring the cement? Like, is it possible to get away with buckets, or is there the diesel powered mixer that you would want to use?
For convenience, it's probably better to use the mixer. Number one, because we're gonna be mixing a large amount of concrete cement that we would want to be using in just buckets. Considering the volume we need to mix, that's one thing. The other thing too is it really is preferable to leave as little time between the pours as possible, to kind of go in big batches and dump it in. And, the professor I talked to suggested maybe doing 3 big pours and that's it. So it might be hard to maintain constant consistency if we have lots of small batches that we're trying to later combine. So in terms of that, it would probably be favorable to script the thing we had before.
Any other questions?
And this isn't really a huge deal, and maybe doesn't even fall in your realm, but the dirt for the rest of the hole, did you have an idea of when we would put that back in, like once we put the foundation in? or
Right.
Once it,
After we put it in the bowl, we want it to stay stable, given we've likely set the rods, the verticality. We're probably gonna want to wait for the duration of the setting period before filling back in the hole. That way we know the concrete is solid, it's staying there, and furthermore, once it's set and level, the dirt will not disrupt it. We probably shouldn't put it into big stones and rocks, because it might shake or alter the foundation, although it might be a good idea to place them around the base where we can, just add another layer of support and strength. From there, we can probably fill it in with all of the dirt and use whatever's left, spread it out around the area, make a rock garden or something.
Sorry, we didn't have to be able to.
Oh, I didn't notice.
Hey guys, we're the red team. We were tasked with figuring out the strength of our tensile rods and figuring out the wind calculations, because historically Rochester's had extremely windy plates. So we had to make sure that the force from the wind wouldn't break or damage our structure, ensuring it was as safe as possible. For our engineering requirements, we had to make sure it was resistant to human interference, which meant like no one could like push our structure and then have it just fall apart. Yeah.
Limits for system performance, the strength of the threaded rods can limit the wind speed, and make sure we can push it over. On the building materials, we have the threaded rods from Lowe's and aluminum 1-inch square rods, and we have all of that current aspects of assembly. It'll need to be assembled when we get there, because it's getting put into concrete. So, risk mitigation, same with, we can't have it break due to the wind force. And ESW will not be maintaining it, but it should be pretty straightforward. And consulting, the local wind speeds of Rochester, we did online searching, and Carson found information from the National Oceanic atmospheric administration, and that had a lot of data that backed up what we had already found online. And then the strength of different types of steel, we called those and got them to tell us what type of steel the threaded rods were. And then we did more confirmation on that.
So with regards to the actual composition of the steel, it's not 100% certain what we have. Again, we called Lowe's, but they didn't have an exact model for us. We managed to get what we think it is. They had some ASTM standards in their records. And that does align with what about the steel properties has. And that is the A307 low carbon steel. It has a yield strength of 248 MPa, elastic modulus, the rest on the table there. And basically what we did with these calculations is we said, okay, we have this steel. Let's compare it to maybe a slightly better, more expensive steel and see how it shapes up. So in terms of a medium carbon steel, we just took A449 steel. It's typically what's used in kind of really, really heavy grade building assembly. It's either low carbon or medium carbon for things that make up like tall skyscrapers, and has better better specs than the steel we have, not by a whole lot. And basically what we were trying to figure out is, would it be worth it for the price? Can you switch slides? So what we found for around the average wind speed in Rochester is about 8.5 miles per hour. On the windiest day, your average is going to be around 11 or 12. The maximum ever recorded wind speed in Rochester was recorded at the airport at 89 miles an hour, which is way more than anything we will ever get on that site. We took the windiest day average, multiplied it by 3, and use that to run through about what it would, the stresses would be on the threaded rods.
Why 3?
3 was a factor of safety that we just decided to use. If it can withstand 3 times the average high, it should be able to withstand whatever. And then we decided to also calculate a maximum allowable wind speed that our threaded rods would be, which is 72 miles an hour. So at 72 miles an hour, our threaded rods would just exceed the elastic limit. It would move into plastic deformation. It wouldn't break, but it would start to deform. And we found for 25.5 miles an hour, slides. These are just some of the calculations we did, and we found that the stress from 25.5 miles an hour would be about 60 MPa per volt out of our, I think it was 250 that our steel had for tensile strength. I believe that's the last slide. Oh, also, we also have the design for the frame that attaches the solar panel to the top of the post. It's made out of inch square aluminum rods. They're welded together. This is so that they, one, have maximum strength. They don't need to be tightened or maintained at all due to vibration. And they're also tamper-proof. Someone can't just go up and move it.
Do we have people in the club trained for welding?
I think Sebastian can do it, but we've been in contact with people in the machine shop and they agreed to weld it. Yeah.
Okay, cool.
We currently have all of the aluminum rods cut to size, and also we have most of the holes drilled in it. with the exception of the holes that will actually be supporting the bracket that attaches this to the top. We left that open because the bracket doesn't have a solid design down yet, and we don't want to drill holes before we have that. So the overall angle of the frame is 40 degrees. That is the typical solar panel angle for Rochester that would maximize solar gain. And the solar panels, the solar panel itself is attached using nuts and bolts that we acquired through the machine shop. It just goes in through holes in the frame there, and it attaches straight to the solar panel. That's the last slide. Are there any questions?
Did you look into if the panel frame could stay on the pole at the max wind speeds you calculated for the threaded rods?
So,
Because I imagine that's what's catching the wind, right?
yeah, we didn't add the weight of the panel, causing a moment because, the panel's actually centered over the pole. There will be some just due to vibrations, but it might as well be negligible. And with the wind speed that we had, again, it was what, a fifth of our tensile strength per bolt for the 3 times the average wind speed, or 3 times the average maximum. So it shouldn't play a large factor in it. I would be more worried about the solar panel on the mounting bracket with the steel rods below.
Are you worried about the solar panel on the mountain bracket?
It depends on what mounting bracket we decide to use. That design isn't quite cemented yet. If we just use a single sheet of metal, bend it around the pole, screw it into the bottom. Can we go back a slide? Screw it into the bottom of that middle rod and attach the base of that, the little outcropping on the base, to the side of the pole. I can't see that failing anytime soon. We did also get some other threaded bolts from the machine shop. I want to say they're 1.25 inch diameter of steel, and they're 6 or so inches long. So those should, if we just drill through a steel rod and slip those in, those are not going to be breaking anytime soon.
Can you go back one slide? So for this analysis, we were looking at tension on 2 and compression on 2 bolts. Is that what's happening?
Yes.
Okay. Did you consider I assume that compression is not going to be an issue, but did you consider the downward force of the winds hitting the slant?
So the wind hitting the slant and pushing it together? No, because we were only worried about tension, not compression, because
Wouldn't
as
that cancel out some of the tension?
I'm sorry?
Wouldn't that cancel out some of the tension itself?
It would, yes. So we, by not factoring that in, we were actually, I suppose, adding more safety to.
Okay, so follow-up question, is the 72 miles per hour, is that the maximum that you calculated, or is that what you assumed for this analysis?
That is the maximum that we calculated. Using these calculations, so all of these numbers here are for 25.5. Then if you just go backwards, using the tensile strength of this, or the elastic strength. There we go. You get about 75 miles an hour.
Okay, great.
So that's just the wind speed at which it would switch to plastic deformation.
Remind me what the highest ever recorded temperature was again?
89 miles an hour. That was in the
So we're not
airport.
super worried.
Yeah. because again, the actual, Peace Village itself has those, hills shielding it from the highway. And that is also going to be the side that the solar panels are going to be facing. And this is all assuming that it will be south blowing wind, whereas the wind typically goes southwest. Like southwest. So it's not gonna be hitting it direct. It's not gonna be hitting it head on. So basically, as an overview, we do believe that the steel threaded rods we have will be sufficient for this.
Wonderful, thank you.
I'm here to talk about how we're actually gonna be storing the phones on the solar charging station. So, what I was working on was confirming the lockbox design that our team had made earlier in the year. So some of the requirements were to charge at least 6 phones, have the design be accessible and easy to use, and also allow the user to leave the phone in the charger, while they, go and do something else. We want it to be, durable with little maintenance required, and allow it to be, temperature-proof and secure while allowing, access to the inside the box, like viewing access. Additionally, for the engineering side, we want to be able to accommodate the charging components provided by the electrical team. So some obstacles, we had, at the start of the year, we had a bit of an uncertainty as to the exact customer requirements, be number of phones, that sort of thing. We also ran into an unexpected limit in terms of the tools we have available. We're expecting to be able to use a water jet cutter the machine shop had, but unfortunately that's broken, so, yeah.
When's the last time you checked on the status of that?
On the what?
On the status of that?
I believe it was a month ago.
Okay,
But
it's
the-
definitely working now.
It's working out, okay, awesome. I will, yeah, it's good. Good enough.
I
No, when
started
I,
using it the other day, so I'm pretty sure it's working down here.
yeah, when I talked to Rob, you implied that you got down for a long time, so that's really good. Awesome. So yeah, the limits of this performance, theoretically, if somebody were to try to get into the phone case, you could probably cut it open because it's gonna be made out of metal. In addition, the hinges and hasps were bolted on, so again, you can theoretically remove those, but again, I'm not, security in that sense, as long as it's locked, I think that's gonna be good enough to protect the phones in the lockbox. Anything else is, more extra. In terms of the bill of materials, as I said, the box itself will be made out of sheet metal. And we have, the doors, you can see, are going to be made out of plexiglass, to allow, you to see inside and see what's inside the box. So in addition to other things such as the handles and things you can see there, were made out of, we bought off the shelf and just attached to the design. So if you go back here, you can see the design, that's one half of it. And in total, we will hold 6 different phones in those boxes, which are designed to be able to easily reach in and grab your phone. The charging port, the charging USB port will be located inside the box. So you can reach in, plug your phone in, and then leave it there. So again, to manufacture, we'll cut the pieces out, then weld them together or use metal epoxy to attach them together, depending on what we can use. In terms of risk mitigation, file down, cover sharp edges, that sort of thing. It should require very little maintenance. We can provide spare hasps, hinges, that sort of thing in case any of them break, to allow the Peace Village to maintain themselves. Additionally, I consulted with Rob Portland, machine shop operator, in terms of how we'd actually build the design. And so based on that, I made some slight modifications based from the original design we made at the start of the year. So the timeline, so initially at the start of the year, we did some brainstorming. After that, we designed the lockbox in CAD. We reached out to the machine shop, discussed the design. Back then, they said the white logic was down, so we had to make some significant changes based on that. So we did that, and then after that, we did some design review, and that's right now. And then hopefully, So next year, we can start working on actually physically building the design, so we can have that constructed we don't need the actual pole to be installed before this can be installed. Any questions?
Back in your first slide, where is the lock actually going?
Yeah, so, what this design does not have is the hasp that would actually lock the box shut. So we would, that would be over the top of it.
Like a hinge down?
Yeah, have the like it'd be, if you both here and here, and you could, put them together and lock that.
Okay, and then there's like a hinge on the bottom?
Yeah,
So the
there's
door
one on the
opens
bottom.
like a mailbox?
Exactly, yeah, it's not visible in this.
Okay.
Question?
I was gonna ask if you could draw it, but you explained it well enough.
Yeah, Chris.
Nope, I forgot.
What considerations have you made for either like waterproofing it or sunproofing it or like different ways to mitigate like a really hot summer day, really cold winter day, damaging the phones?
Good point. So in terms of waterproofing, it'll be made of metal that's bolted together, so that's not gonna be too much of an issue. We also have a seal around the door, some sort of rubber gasket, so that when the door is pressed against that and locked, then the water will have a hard time getting inside. In terms of hot or cold weather, I think some sort of insulation would help with that. So foam on the inside would be good. I would also paint the box to avoid it absorbing sunlight too much.
So this might be like oddly specific, but I know that like right now we see 3 lock boxes and then there's like I don't know how big it is, like maybe a 3-inch like buffer zone and then the square pole goes in the middle.
Yeah.
So like if I had my phone in one of the 2 adjacent lock boxes, like I have my own lock box, but if are the last 3 inches just like empty communal space, like couldn't I just reach my hand with the other lock box? Like I'm confused what the gray buffer zone is for,
So
because that's just empty space.
yeah, so the buffer zone in there is to store the cables and electronics that would be used to actually, like basically I believe the electronics that would be routing cables up the middle of the pole. There's like a false wall in the back.
So you
This
have
is
a
a false
wall.
wall.
Yeah.
So the pole would come up
So
there.
Oh,
Yeah,
okay,
and
so
the
it's just
bottom
storage
one-
for the
Yeah, it's storage
electrical
for
wires.
wires, yeah.
Okay, cool, awesome, thank you. Thanks. So you can just reach to the other box and just take your phone that
This is
way.
one half, it could be the other half on the other side, so it'd just be around the pole.
Ah, okay, that actually answers a lot of questions. Okay, awesome.
This is probably a minor detail, but is this resting directly on the bench table, or is this like raised a bit?
We have it designed to be just best on the table, yeah.
Does that interfere with the doors hinging downward?
I don't believe it would, no.
Okay.
Maybe it wouldn't be able to hinge all the way down because of the handle, but if you get down.
It's
enough
still
to-
accessible.
Yeah. Still accessible.
I remember what my question was. So, how did your design change when you knew that you weren't going to be able to use the watershed?
So originally, we see there's the 3 different cones. We had each of those be essentially one piece that would be water jet cut, and then folded together. Then since we can't water jet cut things, we need to have more simple shapes that can be machined by hand. So basically each of those, there's a lot more metal pieces that need to be cut down. So for example, each of those faces of the gray box are its own piece, and then those will all be welded together. Now that we know that they do have a water jet, we can probably go back to an older version of our design that's easier to construct. Yeah.
So did the design actually change, or did just the like manufacturing of it change?
I guess more than manufacturing, the actual physical like what shape of it didn't really change that much. No.
So you just said like, well, that they're individual pieces welded together. But earlier you mentioned, when Sebastian asked about waterproofing, that they were bolted together.
I meant welded.
They are welded?
I will, yeah, I think I meant this one.
No problem. Go, Chris.
Okay, that's just an extra slide that I didn't get rid of. So,
I'll go and present that.
so I have a bunch of feedback, if you want to do that.
Yes.
Yeah, nice job, everyone.
Yeah,
That was
this
very
is awesome.
impressive for going up there and doing that like that.
So, the piece of feedback that I have, I'm gonna go to the end and then back up to the start, just to confuse you. But some sort of slide that includes everything, and says like, here's what we talked about today.
Yeah,
That
that falls
seems
more
silly,
on
but-
my part.
Yeah. When you are doing this next, is it gonna be a similar structure with, you know, maybe a representative from each group, or is it gonna be, like, how would you plan on seeing this going for the actual real design?
The next time I would imagine presenting this would be at the city council board,
So just you, or maybe just a couple of you? or-
in which case it would probably be, for simplicity's sake, just Sebastian and I.
Okay.
So we would take their work, but make a couple of changes because it would be an audience that doesn't know anything about this project. So we had more visuals for them to look at, so they know what our electronics and what our design looks like.
Okay, cool.
I would think of how intimidating it would be if 20 people walking.
The room is not that big, so.
We're here to talk about solar panels.
Yeah.
Oh, God. It would show how serious you guys are.
Yeah.
So one thing is that obviously you guys will be there for the real thing, but like I still don't know all of your names. So like an introduction and like, I know that would take more time to tell you guys. Also, the color teams are fine for your sake, because that makes project planning easier. I don't want that on this, obviously, you probably thought of that already, but, the main thing was like, there was at one point, there was it was the, like, concrete. But I was like, I stared at the slide for a second, I was like, can't tell what they're doing. So like that, I want that to be blaring.
Okay.
When you walk through, like you kind of have the agenda at the beginning, but it's a lot. So when you actually dive into it, you know, we're gonna start with the purple team who did this, you know, just kind of re-walking through that same.
Okay, it's like before they go up, or, well, before we present on the.
Yeah, just be like, so to recap, we're gonna start here.
Yeah.
So I know this is something that you guys had thought of working on, but maybe didn't finish or maybe did, but you were gonna do kind of like an exploded view of it. That would be really nice for this presentation of like, here's the exploded view, you know, this team worked on this square of stuff, and whatever. Just to make it more fluid, I guess. The CR-ER acronym, that's something that me and Chris understand from seeing your design, but for their sake, just say, requirements or something like that. When the purple team went, you had a slide that ended with a timeline. Going over that timeline first would have been more helpful for me to understand what you guys were doing. Your like language is like a more powerful thing than I think people realize when they're presenting. And it never catches, the person who's saying it never catches it. It always catches like someone random in the audience of like, I didn't like the way you said that. So just like attention to that. But there was one thing that stood out to me. Don't remember who or when, but someone used the word obviously. And to me, like, it's a little insulting, like that wasn't obvious. Just little language things. Oh, there was a question of like, should I transition the slide while we like take, 20 seconds to kind of like digest? And there are like the pros and cons of that. Like maybe that slide was really word heavy and you went through it quickly, so I need time to digest it, maybe ask some follow-up questions. But if we've gotten through all of that, then transition so I can read the slide before you present it to me. Otherwise, like you just dive right in, and that's really hard to, especially with this much text, which it is kind of necessary, but it's hard to digest everything. So if you need a pause, your time to transition the slide. So for the one where you're comparing the two steel types, the first one is clear that you have that steel. The second one, I'm like, but what is that? We're like, I'm too focused on why are you comparing these two? All I needed to see was like, this is our like ideal steel. And to make it obvious of like, here's what we have versus like our ideal, like the first question is why don't you have your ideal steels is price. So showing the two prices would be pretty nice. Again, maybe that's not important to your next audience, but it was important to us. Yeah. So you had this whole, I kind of like explained it, but definitely didn't address every part of it. You have all this space to work in, you're still on the screen. But there were a lot of times where people would kind of like point at the screen, but like walk right up to it and say like, I'm talking about this, or get a laser pointer for your presentation. And the last thing I want to ask each group, and I'm sorry, Lainey, I'm gonna put them on the spot. I want each group to tell me what their biggest risks are. Starting with the purple team. Wait, we gotta go in order.
Electrocution?
So, okay, so go over like the highest impact. So like, that's probably the worst thing that could happen is you electrocute someone, but also the highest probability. Like, what do we actually anticipate going on? What are we gonna do
We have
about
to
it?
replace them. Or they get short-circuited. I think the batteries are probably the weakest portion of the design. There's a lot of things that we had to adjust around them, but they're also one of the things that we need for it.
So little things where it's like, you don't want to tell them that up front, but if they ask, you're gonna want to know that that's the weakest point, things like that.
Now, have you found ways to mitigate some of those problems?
Yeah.
Okay, so out of the things that you haven't mitigated, what is still the biggest risk?
We need to figure out grounding and wiring and making sure that there's no arcing in the system.
Okay.
It's like when you get the electricity transfer, yeah.
So, solar panels are DC current, which means that, when they're transmitting, voltage, it's going to be high voltage, and it's going to be constant voltage. So AC, is turning off and on like 60 times a second, but you don't have that with DC power. So for a solar panel, if something fails, there's a bad connection, you can get an arc, which is literally the panel makes lightning and burns itself down.
Arcing can happen with any electrical circuit. That's happens to be a conflict.
Because of the DC.
It's just when you have a high enough difference in electric potential voltage, the air becomes conductive.
What's the biggest risk?
What are your biggest risks that are mitigated?
Stress fractures caused by some failure of design or misalignment of the poles, causes collapse, speed affecting, injury, perhaps fatally.
God.
The biggest risk, there's not, I mean, we basically have to go out there and pour it. Like, that's really the biggest risk, is when we go out there and pour it, it has to be done right the first time.
So you talked a little bit about like a intro presentation. What has that successfully mitigated in that line of things? Or like, is it kind of up to them to kind of relearn this stuff and really understand how to pour this correctly? Or is it really up to
down
chance?
just about everything we've learned. Honestly, it's not that hard a process. You can go and figure out what we did, maybe looking at some tutorials and things online, as well as some stuff we linked in that presentation. Basically, the three big things are the atmosphere, it has to be correct weather conditions, especially during the setting period, the mix consistency, and for the different section, and then, I guess, proper protocol while doing so. No pieces of like large flat pieces of metal that can cause fracture points, make sure things are properly aligned. All those three things go right.
How can we make sure things are properly aligned out in the field?
So there's a couple different ways. For one, we have a mesh of wires holding the rebar in the frame itself. That will be concrete put around that, and the threaded rods are aligned through there. They're then aligned at the top by a steel plate that holds them at the exact dimensions we want them to be. And ideally, we will slot that plate on with the 4 rods and then put nuts on the top. We can just hold that there, both aided by the wires and by people, or a kind of apparatus we can make with a level on top, just to make sure everything is straight and narrow, and then just make sure that's stable until it's set. Remove the nuts, take the plate off, fine.
I'm also still waiting to hear back from the civil professor to see what, she mentioned something called chairs, which are used a lot of times in legal applications that are horizontal. But she mentioned it in our case, and I didn't get a clear word from her about if there's some for vertical applications. So that's more standardly used in the field, so if she has a good suggestion in that respect, we may go that direction as well.
Do you know, have you asked about any students that might be interested in helping us or anything like that?
I wouldn't know how to
Bad
find
idea.
those people, but, I think the people we've talked to have done a lot of concrete work, so, they have some concrete ideas on this.
Yeah,
I think my biggest worry is with you guys going on co-op, finding the right person to take over this job.
I mean, we can contact, whatever, I don't know the civil engineering professional club, but maybe talk to them. Or, I do in front of the department, see if I can probe and see if she knows any students, meaning like, if they would do before.
I guess just kind of like
otherwise-
digesting the knowledge that you have and being able to supervise that process.
Yeah, I don't
Which,
know.
I mean, that
sounds
could be
like
Lainey or
something
Sebastian, but it
Okay.
could also be us.
Yeah,
That's up
W
to
has a lot of
Lainey,
smart
so.
people, and not to downplay our great intelligence, but, the resources are out there. It's not a horribly complex process.
We do need to make sure we get it right the first time, because they're
Right.
new orders. So, I mean, that's the risk, what's on this one.
Well, we can move on, I kind of get you. I don't remember what color yours are.
Red team?
Red.
Red.
Okay, so there's two big risks associated with grid. Either the steel rods could fail, causing the entire structure to collapse, again, potentially injuring, perhaps fatally, a group of people. That likely will not happen unless someone hits it with a car.
Okay, hold on right here. There's a difference between risks and risks.
Okay, so the
So-
biggest issue that I can see with this design is the bracket that attaches the frame to the top of the steel pole. That's the main reason we haven't constructed and welded together the top frame yet, because that is what I view as the biggest structural weakness of the entire thing.
Do you have a plan for addressing that?
Not currently.
Do you plan to have a plan for addressing that?
Well, when we switched off the, when we started switching teams, we were kind of taken off of that aspect of the design.
So
And
whose
that was
job
put
is
on
that
hold.
currently?
Is it anyone's job at the moment? It was
I know
mine
you-
kind of on the down low.
Yeah, I know you and Jake worked on the beginning, and then it became a medium priority
Yeah,
while we were figuring stuff out, so it hasn't been officially signed.
so that.
I have a question. So Matt, you're going to co-op next semester.
Yes.
So Katie and Ben, do you feel comfortable with this, or or has Matt given you the resources you need? Or what are your thoughts on this for continuing this next semester?
I think we have all the resources that we need, and if we do have questions, we can always ask some.
Yeah, I'm not expecting you guys to have all the answers, but the confidence to move forward and the ability to ask, so.
I'll also be available for, talking over the group meet. It's not like I'm falling off the face of the earth.
Carson, you're up.
Yeah, yes. I would say the biggest risk for now is sort of the weatherproofing that Sebastian asked about. We haven't fully looked into exactly what how hot the inside box could get if it's a really hot day. I don't think it'll be too an issue, but it's not something we specifically looked at so far, so that's definitely something to consider. Besides that,
Who is taking over this project or this part of the project, assuming you're on co-op, not Rochester next semester?
well, I'm not sure if you ever
Yeah, we were.
Everybody.
Literally everyone's on co-op
Just
next
making sure that,
semester.
like, there's plans in place, but if there's not, that's okay.
Except one to cry.
So I guess the next question is there enough documentation for the people, like, I think we've mitigated most of it because they're in teams, but is there enough documentation for your team to pass it on to someone?
there's documentation, I need to make sure it's available to other people. Mostly in the form of the on-shape documents that I have of the actual design, that I definitely need to get that into other people's hands.
And then, Sebastian and Lainey, what are the biggest project risks?
Personally, it's working with the city as a customer and figuring out a solution that we can facilitate within the timeline. Because right now they seem to be the biggest obstacle of making real progress.
Yeah, I was wondering if you were gonna say something about the city. Yeah, I mean, I really do feel like we have a solid design, the work you guys have put in, I think we can definitely pull this off, it's just a matter of actually doing it, and unfortunately, that's kind of dependent on outside, well, that's dependent on people outside of our control. So, yeah. And then I guess in terms of the design itself, I have some hesitations with how everything for the electrical components are gonna come together. Just because I know that I don't have a big familiarity with the components and I wouldn't, I don't know, electricity just makes me uncomfortable. And just making sure everything is like wired up correctly, and that's kind of something that we can't mess up. But I think that you guys are on the right track and you're doing your due diligence for what you need to, so. It's just like kind of me putting my blind faith in you guys.
So it's kind of a wrap up of what I want to say is this was really great. I'm really glad you all like prepared for this. Like you guys crushed it and like exceeded all of my expectations in every way. So keep doing that. Also, thank you both for inviting me and Chris to this because I think it's really valuable kind of for everyone. And I do want to ask Morgan to share this video and kind of say like to other teams that might be doing something like this in the future. Like I think this is really valuable to other people. To end the, like at least what I have to say on a high note, I want to know what you guys are most looking forward to on this project next semester.
Can we pause and get brownies and cider first? And then
Yeah.
Okay. This, because I know it is late and I just like really want a brownie. And then we can reconvene.
And if anyone else had anything negative to say, do that first.
Yeah.
Bye.
That mounting bracket there.